Hello everyone. In this video, I'm going to discuss about binary search. Why do we need binary search? Binary search can be useful for academic purposes, for competitive programming, interviews, and so on. So let's get right into it. The contents that will be covered in this video are linear search concept and why not use linear search, how binary search algorithm works, pseudocodes, Python codes, and time complexities, and drawbacks of binary search. So let us first see what is binary search. So let us assume we have an array 10, 23, 67. These are the elements of the array, and we want to find 2 in this array. So for that we have a pointer called I. So if we start from the first element, then let's first check the first element. Is ith number element is 2 or not? It's not 2, so we go to the next element. It's again not 2, so we go to the next element. Then we go to the next element and it is 2, so we have found 2. Now let's think we want to find 10, and 10 is the first element, so we need to do it just once and we have found the element. But what if we need to find 8? We can see 8 is the last element of this array, so we actually need to go from 10 to all other uh, elements and check if it is 8 or not. So why do we do this? For linear search, the best case scenario is that the item is in the first element. So when that happens, the time complexity becomes log O of 1. And the worst time complexity of this is the element is at the last position. So that at that time the time complexity becomes O of n. So in average the time complexity becomes O of n divided by 2, which is also O of n. Now let's see how binary search works. For binary search, we'll need an array which must be sorted. This is the prerequisite of binary search. The array must be sorted, and we'll need two pointers, left and right, and we'll try to find some value. In first case we're gonna find 14, and we'll every time find the mids value. So let's start our binary search. So at first the left is 0 and right is 10. So 0 plus 10 divided by 2, which is 5. This is the value. Now we can see that this value is clearly greater than our target. So we can easily say that this value needs to be in this part, right? So we can actually discard this total thing and only consider this part. So basically our right needs to be here, I mean here. So we can only consider this part actually, right? So let's do that. So now we will check for this portion. Now for this portion, the left is again 0 and right is 4. So dividing that 2, we get 2. So this is the value. Now this value is lower than our target. So we can now say that this value, I mean the target's value can never be here, right? Because this is a sorted array and this needs to be after this value, right? So basically we need to put this right after the mids value, right? So let's do that. Okay, now we can see that the left is 3 and right is 4. So 3 plus 4 divided by 2, which is 4 plus 3 is 7. 7 divided is 3.5. However, we'll do not take this floating value, we'll take that integer value. So this 3. So is the mids values index's value is equal to target? Yes, it is equal to target. So we found the we find the value using binary search. So we needed only 3 tries. Now let's try to find 45. So for 45 we again start from L in 0 and R in the last position. So at first the mid will be sorry so the mid will be 0 plus 10 divided by 2, which is 5. So this is the value. Now this value is clearly lower than this value, so we can easily say this value cannot be here. We need to consider only this portion. So this L needs to be here. So let's do that. Okay, now in this scenario L is 6, so 6 plus R is 10 divided by 2, which is 16 divided by 2 is 8. So this is our mids value. Is it equal to target? Yes, it is equal to target. So we found our index 8 in only 2 tries. If we wanted to do it in a linear search, we need to go from here to here. We need 9 tries. So and we did it in 2 tries in binary search. Okay, now we have established 3 things. There will be 3 conditions. The 3 conditions are, these are the 3 conditions. The mid value can be equal to target, it can be less than the target, or it can be greater than the target. If it is less than the target, then L becomes mid plus 1, and if it's greater than target, then right becomes mid minus 1. This is simple, right? Now what if the value we are looking for is not in the array? What will we do in that case? So let's see. For one example, let's try to find 25. 25 is not in this array. So at first we'll do the same thing as well. So L is 0, so L is 0 and R is 10, which will be 5. So this is the 5. Now this value is clearly lower than the target, so we'll discard this part and L goes to here, right? So let's do that. Now the mid value will be 6 plus 10, which is 16 and 8. So this will be the mids value, right? And this value is greater than target. So this value is greater than target. So this condition satisfied, right? So what do we do in that case? We make the R value mid minus 1. So it becomes R becomes mid is 8, 8 minus 1, which is 7. So R becomes 7. Let's do that. Now in this case uh, the mid is 6 plus 7, which will be 12, 13 and 2 is basically 13 divided by 2 is 6.5, and we'll take actually 6 because we'll only take the integer part. So now let's see, mid is 6. Is 6 25? No. And 25 is less than this value, right? So again this condition is satisfied, right? So if that is satisfied, then R becomes mid minus 1. Mid is basically 6 minus 1, which is 5. So R becomes this one. Let's do that. Now we can see left is now not in left. It's basically not doing the right thing. So in that case, we are gonna say that the value is not in the array. We'll actually discuss it nicely in the code portion. So if right goes to left, then it becomes, I mean, the right's value becomes greater than the left's value, then we can conclude that the value is not in the array. So that's it. Okay, so let's try to code the binary search. We make an function called binary search. This is the array, and this is what we'll be trying to find. Let's try to find 14, and this will be the result. So at first, in binary search, we'll take two things, the array and the thing that we need to find. So, and at first we'll take the left equal to 0, and right should be the length of the array minus 1. It's because the length of the array is minus 1, so this index is right. Then we can take mid's value anything because it will be replaced anyhow. Now here will be a while loop which will be called for left is less than equal to high, I mean right. This means that if left somehow becomes greater than right, so that means that uh, the value was not in the array, right? So at that time we need to stop this, right? So at first the first condition was, oh, first of all we need to find the mid's value. So for that we'll write left plus right. We're using double divide because it's gonna give us the integer value. Then there will be conditions. So first condition, if the array's mid value is, I mean, equal x, then we basically found the mean value and we'll return mid. Else if the array's mid value is greater than, I mean less than the x in the value, then we need to make the left's value mid plus 1, or else we need to make the right's value mid minus 1. And if the while loop totally ends and the left becomes greater than right, so it means that the value was not in the array, so we return minus 1. So if this is minus 1, then it means that the value was not there, so we can write if condition at outside, that if result minus 1, so we print value not present, and else print value at result index. So let's run it. We can see value at her 3 index, so 0 1 2 3. It's giving us right answer. Now let's try to find 47. Value at 9 index, 0 1 2 3 4 5 6 7 8 9. So our binary search is working. That was the code of it. Now let's discuss the time complexity of binary search. So we can assume that we have an array of 100 elements. So 100 becomes 50, 50 becomes 25, and so on, and at last it will become just one element, which is our desired element. Now if we describe it as n, so n becomes n by 2, n becomes n by 4, n becomes n by 8, and so on. We can write it as n divided by 2 to the power 1, 2 to the power 2, 2 to the power 3, and this 1 can be written as n over 2 to the power x. As you can see, it's going upwards, so the last value will be something like this, which is close to 1. If we consider this part, we take the 2 to the power x to the here, so n becomes 2 to the power x, and we can see this is basically x equal to log of 2 of n. So in each iteration, the search gets reduced to half of the array. So for n elements in the array, there are log of 2 of n iterations or recursive calls. So time complexity of binary search is log O of log of 2 of n, which can also be written as O of log of n. However, there are some drawbacks of binary search. It is more complicated than linear search. As you can see, linear search is very simple and easy to use. Also, this is sometimes overkill for small number of elements. For something like 2 or 3 elements, it's easier to use linear search. Also, for binary search, the arrays must be sorted and needs to be sorted throughout the search, which is sometimes not possible, especially when we are constantly adding elements. So for those, we need some better search algorithms than binary search. So these are the drawbacks. Thank you so much. That was all about binary search and its things. Thank you.